We're going to start today by really getting going with our three-dimensional shape stuff, and we're going to talk about surface area. Surface area is just basically the area of all the faces of a three-dimensional shape. Another way to put it, I wrote it on here, it's the combined area of all the surfaces of a three-dimensional shape. And I'll give you some examples right now of what that means. If you take this box right here, okay, this is a rectangular prism. Surface area would be the total area of all the surfaces of this box. And we would have 6 surfaces because we have 6 faces. We would have this, we would have the back, we would have the top, we would have the bottom, and we would have the 2 sides. To find the surface area, or to find out basically how much packaging we need on this, we just need to find the areas of everything separately and then put them all together. We're going to do today one example together, and then I'm going to have 3 problems for you to do on your own where you can use the videos to check. Save all your work. You're going to draw out some diagrams for me, and this is what you're going to turn in the end. Pay close attention to the example problem, because this is exactly how I'm going to want you to do your work when you do these problems. Okay, so let's start off with this. Okay, this is my favorite cereal, Kix cereal. Okay, it's about the blandest cereal you could find, but it's the only cereal that doesn't have like 80 grams of sugar per serving, so I eat it. One thing we would use surface area for, like a company would use for this box, is how much packaging they need for this box. And we're going to do a little, I guess, mini project coming up here where you're going to design a cereal box and find the best surface area for the amount of cereal that we have. The goal is probably for a company to use the least amount of cardboard possible, because that's going to cost the least amount of money. So what I want to do is I want to take this box of Kix and I want to find the surface area of the box of Kix. Okay, so if you think about this box of Kix, we've got the front, we've got the back, we've got the 2 sides, we've got the top and the bottom. So we need to find the surface area of all of those faces and then put them together to see basically how much cardboard we need to use. So I've kind of got the measurements kind of predetermined here. This right here is what I am going to want to see on your assignments that you're going to be doing. This is what I want to see for all of them. So diagrams. Now you don't have to draw the pictures inside of them. I just drew them so you get a kind of an idea of what the box would look like. But I've got my front and my back, and I'm doing this all in. We'll just use centimeters. I think that'll be the easiest thing to use. We'll use centimeters. And basically I've got the front is 32 by 24. So then the back is also 32 by 24. The sides, we've got 32 by 7 and 32 by 7. And then the top and the bottom are 24 by 7 and 24 by 7. So I just need to find the combined surface area of this box. So what I'm going to do is I'm just going to find the area of each one of these surfaces, because if you think about it, if you take apart the box, you have 2-dimensional shapes. You've got a rectangle, a rectangle, rectangle, rectangle. You got 6 rectangles. So I'm just going to start with the front and the back. To find the area of a rectangle, it's just easy. It's just length times width. Okay, so I'm just going to do my 24 times 32, and I'm going to have an area on this one of 768 square centimeters. So that means that we would have 768 centimeter squares that would fit inside of this. Now, I'm just going to take it times 2, because we've got 2 of these surfaces that are exactly the same. So if I multiply this by 2, I get 1,536. This takes care of the front and the back. Okay, so let's go to the top and the bottom. The areas for the top and the bottom are going to be 24 times 7. 24 times 7. The top is going to be 168, square centimeters. We can fit 168. If you look in the back, you can kind of get a good picture. Underneath that letter E, there's a picture of what a square centimeter would look like. This number means we can fit 168 of those in the top of the box on the cardboard. And then the bottom's the same thing because they're the same size, so I'm just going to times that by 2. And I get 336. So this takes care of the top and the bottom. You don't always have to times them by 2. It just depends how many you have. Some of the ones you're going to do, every one of the surfaces is going to be exactly the same. So you could just find one of them and essentially times it by 6. But you got to take all of them separately and see what sizes they are. Now let's take the sides. Okay, the sides are exactly the same. They're 32 by 7. So I'll just do 32 times 7. So I've got 224. And we've got centimeters squared, square centimeters. We can fit 224 of those squares on the side of the box. And then we've got 2 of the sides, so I could just times that by 2. And I'm going to get 224 times 2, which is going to be 448. So now we've got our area for our front and our back, area for our top and our bottom, area for our side and our other side. We got 6 faces figured in here. Now we just need to add these all together because we want how much cardboard this thing takes up a grand total. And a grand total, this Kix box, all the surfaces together would be 2,320 centimeters squared, which means that to cover the whole box, we would need, and if you look back behind that letter E, we would need 2,320 of those square centimeters to cover this entire box. So essentially all we did was find each area of each face separately as if they were two-dimensional shapes, and then we just combined everything together to get 2,320.